So to make sense of the least squares criterion, I'm going to kind of demonstrate how we would fit a line using this sim. So this is PHET, P-H-E-T, least squares regression, which you're welcome to Google search and follow along with, or you can just kind of watch me here. But what we're going to do is recreate a scatter plot, and then we're going to talk about how we would fit a line and talk about how we would know what the best fit line would be. So let's say that these two variables, I have an x variable and a y variable, and maybe I'm interested in whether there's a relationship between how many hours a week students spend on social media versus how many hours a week students spend outdoors. So we ask some students these two questions, and here we have one student who said they spend 10 hours a week on social media, 5 hours a week outdoors, and maybe we just collect other data from students, and I get something that looks kind of like this. There's going to be a lot of variability, I'm sure, because there's many things affecting how much time students spend on social media or outdoors, but maybe we generally see a bit of a negative correlation here, where the more time people spend on social media, the less time they're spending outdoors and vice versa, but certainly with a lot of variability as well. So if I was trying to model a relationship between these two variables, I would need to find kind of an appropriate y-intercept, and then I would need to find the slope here. So maybe I do something kind of like this, where I think this line's kind of a reasonable fit here. It kind of tells me a little bit of what the pattern is. Again, there's a lot of variability. It's not a perfect fit by any means, but knowing how much time someone spends on social media might give me a little bit better sense of how much time they're probably spending outdoors. This is probably better than just assuming y bar as my best guess across the board. So I can also see the residuals of this line, and a good line is going to reduce the total amount of the sum of residuals to the smallest value. But if you remember mathematically, residuals can be positive or negative. And rather than taking absolute values, which can be algebraically kind of messy, statisticians and the formulas that we use instead like to square these kinds of values. So what we actually do is we take the squared residual value, because these are all going to be positive values if you square them. And absolute values do weird things in higher level mathematics, which is why they're avoided in the formal calculations. So instead what we're going to do is we want to minimize the total sum of squared residuals in this case. So I want to find a line that makes this as small as possible. And you can kind of see this down here, right? So where would I get the smallest sum of residuals? Would changing the slope give me any help here? Right, and so this is kind of a tricky process, right? Because I could play around all day, and it would be kind of hard to know exactly, what the smallest one would be. So there is actually a mathematical formula that you would learn in a regression course about minimizing this value. You could use a maximum likelihood estimator, and you could use derivatives from calculus to find the equation that makes this the smallest possible. And apparently the true line that minimizes the sum of squared residuals to the smallest amount is actually this one, which might have taken me a little bit of time to get exactly right. But this is apparently the line that minimizes the sum of squared residuals to the smallest possible value.